Hello students, Namaste. In today's session, I am going to explain one of the important topic of this particular chapter. The reason why it is important because most of the question in the competitive exam, that can be CT, can be NEET or NJE, is from this particular concept. So that's why this is very important concept in this particular chapter, and it's called dimensional formula. Now, to understand this dimensional formula, first let's learn the fundamental quantities that we have discussed. Now, which are those fundamental quantities? You know the 7 fundamental quantities, starting with mass, length, time. Correct? 3, mass, length, time. After that, I'd ask you to remember the word late, L-A-T-E, late. L, luminous intensity. A, amount of substance. T, temperature. And E, electric current. So, these are the 7 fundamental quantities. Now, these 7 fundamental quantities are expressed in terms of a formula which is called dimensional formula. Now, what exactly the dimensional, how to understand that the formula is a dimensional formula. For example, let's start with the term mass. Now, what is the first letter of that word? It's M. So, the dimensional formula of the mass is written as capital M. And then we write within the square bracket. So, moment you draw that square bracket, it indicates that it is the dimensional formula. This is a standard representation. Clear? So, for mass, it's M. Now, what do you think for length? So, the first again letter of that L. So, this is L, the dimensional formula. So, moment I write M means I can very easily understand that it's mass. Moment I write L means it's the length. Okay. Okay, what next? Time. So, definitely it's a T. Right. Now, for the rest of the term, like luminous intensity, what is the first letter? L. But I can't use that again, right? Why? Because we have already used for length. So, for luminous intensity, what is the SI unit? It's a candela. What is the symbol used for that? CD. And that is the dimensional formula used for luminous intensity. Amount of substance, what is the SI unit? It's a mole. So, MOL is the dimensional formula of it. Are you clear? And now you can very easily tell me the rest of the 2. For temperature, the SI unit is Kelvin. So, we use the symbol used for the Kelvin, which is capital K. So, the symbol of the rest of the 4 quantities are used as the dimensional formula. Are you clear? Symbol for luminous intensity, candela is the unit, symbol is CD, and that's what is used. For amount of substance, mole is the unit, MOL is the short form used as the symbol, and that's what is used as the dimensional formula. And bracket, understood, bracket will signify the dimensional formula, but sometimes they avoid that, okay, bracket. So, it's not mandatory to write the bracket, but moment you write the bracket, it indicates that it is the dimensional formula. Okay. Temperature, Kelvin is the unit, K is the symbol used. Okay. Now, what is the SI unit of electric current? The SI unit of electric current is ampere. So, what is the symbol used? A. So, this is the dimensional formula of the fundamental quantities. Okay. With the help of these, I can write the dimensional formula of all the rest of the quantities. There are so many physical quantities are there, right? Velocity, speed, momentum, force, acceleration, correct, displacement, energy, torque, and so on, correct? So, for all that, I can write the dimensional formula. And based on the dimensional formula, we have certain application, we have certain, that is, application means the uses, okay, advantage. There are advantages, there are disadvantages also, and that's what we are going to learn in this concept called dimensional formula. So, hope you have understood the dimensional formula of the fundamental quantities. Do remember them, it's very important. So, for mass, it's M. For time, it's a T. For length, it is a L. For temperature, it's a K. For electric current, is a A. amount of substance mole, and for luminous intensity it is CD. So based on this, let's learn the dimensional formula of some more physical quantities. And you have to remember all these dimensional formulas of the quantities which we are going to derive right now. Okay. So let's start with these quantities. So there are certain derived quantities are there, like area, volume, density, then there is a velocity or speed. After that we have momentum or impulse and so on. Okay. So we have few more list of physical quantities. So we will derive one after the other. Okay. Right. So I'm going to start with the first physical quantity now, which is the area. So I'm going to write here. So this is area. You know, I can write area of the circle, I can write the area of the square, I can write the area of the rectangle. For any, it is valid. Okay. So let's take the simplest structure, you know, which I'm going to take rectangle. Okay. How do you find the area of the rectangle? Area is a length into the breadth. Okay. So I've written just the expression for it, basically, correct? Now let's write this in terms of the dimensional formula. I'm going to write the symbol for area as A. Okay. So that you'll come to know that this is the dimensional formula of the area. Now tell me, for length, what is the dimensional formula? It's L. Breadth is a measure of length only, right? Breadth is a measure of which fundamental quantity? It's a length only. So that means I have to write another L. So for breadth there is no separate dimensional formula. We don't write it as a B. Breadth is a which fundamental quantity basically? It's a length, right? What is the unit of the breadth? Meter. Length is also measured in meter. Okay, right. So it's L. What is L into L? It's L square. So there we are. This is the dimensional formula of area. So what is the dimensional formula of the area? It is a L square. See, what you can understand out of that particular dimensional formula? We can understand that area depends only on one fundamental quantity, which is length. It is independent of mass. It doesn't depend on the time. It doesn't depend on the luminous intensity. It doesn't depend on the rest of the quantities like temperature, electric current. Are you clear? And the moment you write the dimensional formula, you can even write the unit very easily. You know, L, length, unit, meter, power, square. So meter square is the unit of area. Understood? So therefore a formula, see, this is a formula in which a physical quantity is expressed in terms of fundamental quantity is called the dimensional formula. So what is the dimensional formula? A formula in which a physical quantity, this is a physical quantity, is expressed in terms of the fundamental quantities. Which is the fundamental quantity there? Length is the fundamental quantity. I hope you are following and hope it is clear. Okay, let's go for the next, because we have many more quantities to be derived. I'm going to derive now volume. Okay, volume. So for volume, again I can use a cube, I can use a cylindrical structure, I can use a sphere, anything we can use it. Okay, so let's go for something different. I will use the sphere. What is the formula for volume of a sphere? Volume of a sphere is a 4 by 3 pi r cube. That's the formula, correct? Volume of the sphere. Okay. Now volume, when I write volume, I have to write it as V. That's the symbol used, notation. Now look at this. 4 by 3 pi is a constant. Constant has no unit. Correct? There is no unit for that. So when there is no unit, definitely there is no dimensional formula. That means we are left with only R. What's R? Radius. Radius is a measure of which fundamental quantity? Radius is a measure of length, because the unit of the radius and unit of length is the same. So that's why the dimensional formula of the radius is L. What is the power of it? Cube. So therefore L cube is the dimensional formula of the volume. Is that clear? L cube, L, again you can see volume depends only on the length. Cube, L in meter, cube of it. So meter cube is the unit of the dimensional, unit of the volume. Okay. So let's go for the next quantity, which is density. How do we measure density? Density is nothing but mass by volume. Correct? It is the ratio of mass to volume. Mass, again it's a fundamental quantity, right? So what is the dimensional formula of mass? M. M is the symbol used. Dimensional formula, I am not talking of the unit. Unit is kilogram. Right? Divided by volume. What is the dimensional formula? It's already there, right? So L cube. Now you simplify this. Take L to the numerator. It becomes M L to the power minus 3. So that is the dimensional formula of the density. So what is the dimensional formula of density? ml to the power minus 3. Density is equal to mass by volume. Now again you can see that density depends on two fundamental quantities. Which and all? One, it depends on the mass, and the other depends on the length. Correct? Which are the two fundamental quantities on which it depends. The formula is mass by volume, that's true. But which fundamental quantities on which it depends? It depends on the mass, it depends on the length, and it is independent of all other fundamental quantities. I hope you are clear with this. Next, we have velocity or speed. Now, why I have written within the same bracket? Because both the speed and the velocity you will be learning in detail later. Okay, don't worry about the unit, all that. Correct? We will be learning more about it. We are going to learn even the types of the velocities, like instantaneous velocity, uniform velocity, average velocity, and so on. Clear? So for time being, just will focus on only the dimensional formula. Velocity and the speed, they have the same dimensional formula. That's why I've written it within one block. So if they ask in the exam, mention a pair of physical quantities having same dimensional formula, then you have to write the answer as velocity and speed. Similarly, I have written momentum and impulse. Okay, so this is a new term to you all, I believe, that's impulse. Again, we are going to learn every physical quantities later in every chapter. Okay. So right now, just focus on the dimensional formula of these quantities. Right. So which is the other pair of physical quantities having the same dimensional formula? One is momentum and the other is impulse. One pair is speed and velocity, which is the other momentum and impulse. That's why I've written it together. Okay. So I'm going to start with the velocity. Right. And by the way, here density I can write like this, d symbol. D is equal to ml to the power minus 3. Okay. So now I'm going to write velocity. Velocity. What is velocity is equal to? Velocity is equal to, so you all know the ratio of the displacement divided by the time taken, correct? Displacement by the time taken. Okay. So velocity symbol I will write V. What is the dimensional formula of displacement? Displacement is nothing but a measure of length actually, correct? It's a measure of length. What is the SI unit of displacement? Meter. And meter is the unit of length. Therefore, what is the dimensional formula of displacement? It is L. Time, what is the dimensional formula? Again, one more fundamental quantity. It's a T. So, what is the dimensional formula of it? L T minus 1 is the dimensional formula. Okay. So, velocity and the speed both have the same dimensional formula. What it is? Lt minus 1. What this indicates? Velocity and the speed depends on two fundamental quantities, which and all? Length and the time. And based on that, can you tell me what is the unit of the velocity and the speed? L, unit, meter. T, time, unit, second. So, what is the unit? Meter per second is the unit of it. Isn't it easy to write the unit whenever you know the dimensional formula? Or if you know the unit, you can write the dimensional formula, vice versa. Okay. So, therefore, pair of physical quantities having the same dimensional formula is nothing but velocity and the speed. Okay. And let's go for the next, for which I'm going to clear this part of the board. So, how do you measure momentum or impulse? Okay. So, remember this some term called impulse of force. Okay. Later in chapter 5 we are going to learn about it. So, not to worry, just remember momentum and impulse. Okay. Pair having the same dimensional formula. How do you measure momentum, by the way? Momentum is nothing but product of mass and velocity. Product of mass and velocity. Momentum symbol used is a small letter p. Mass capital M. Velocity, we know the dimensional formula, right? LT minus 1 from the previous discussion. So, what is the dimensional formula of momentum now? It's m l t minus 1. Now, can you tell me, velocity depends on how many fundamental quantities? Only two, length and time. Whereas, momentum depends on three fundamental quantities: mass, length and the time. So, here LT minus 1 multiplied by mass, you will get MLT minus 1. So, all these dimensional formulas you should know by heart. Just go through it repeatedly. Okay, you can remember area L square, volume L cube, density ML to the power minus 3, not M, ML to the power minus 3, mass by volume, correct. Velocity LT minus 1, then momentum MLT minus 1. So, like this, if you are very fluent, then you can understand all the rest of the topic better, and then you will be able to answer the objective type of questions very easily. So, hope you are clear with these dimensional formula. We have a few more dimensional formula. So, that is what I am going to explain next. So, see the next set of physical quantities. So, these are the next set, okay, and then so we are going to stop here because these many dimensional formulas are enough for our discussion. For every physical quantity we can write the dimensional formula, okay, right. So, let us go for the next, acceleration. So, what is acceleration? The symbol for that is A. Acceleration is change in velocity divided by time. This is how we measure acceleration. It's called rate of change of acceleration. You all know all this. You have learnt in your lower classes. Now, numerator change in velocity. So, I know the dimensional formula of velocity, which is LT minus 1 divided by time t. So, simplify now. So, what do you get? L t minus 2 is the dimensional formula of the acceleration. L t minus 2. So, for velocity it is LT minus 1, for acceleration LT minus 2, okay. What is the unit based on that? L length meter, time t second. So, meter per second is the unit of the acceleration. Clear? There are three quantities having the same dimensional formula. One is a force, other is a weight, and the other is a tension. Tension again is a force. It's a kind of a force that normally acts along the string thread, okay. So, again no worries. So, all that is later in some other chapter, okay. So, time being, which are the three quantities having the same dimensional formula? Force, weight and the tension, okay, right. How do we measure the force? The basic formula, force is equal to ma. Ma means mass into acceleration, correct. From the Newton's law of motion we know it, we can derive it, F is equal to ma. So, force symbol F, mass is m, a is acceleration, we know it already here, LT minus 2. See, they are all connected, linked. So, there we are with the dimensional formula of the force, weight and the tension. What is that? That is ml t minus 2. See, easy to remember, velocity LT minus 1, momentum mlt minus 1, acceleration LT minus 2, force is mlt minus 2. Just multiply by mass. That is the way to remember. That is why that sequence is given. Clear? Okay. So, that is force, weight and tension. Next, Work and energy. See, we have plenty of quantities, pair of quantities having the same dimensional formula. One, speed and velocity. Then we have impulse and momentum, force, weight, tension. Now work and energy, pair of physical quantities having the same dimensional formula. Okay, right. So work, energy. Now, how do we measure work? Work is nothing but force into displacement. So work is W, symbol. Force, it's here, ml t minus 2, into displacement, which is a measure of length again. So on multiplying, you will get ml square t minus 2, ml square t minus 2. Correct? L into L, you will get L square. So it's m L square t minus 2. See the difference here. Here m L t minus 2 is the force. ml square t minus 2 is the work or energy. Next we have again another pair of physical quantity called pressure and stress. How do we define pressure? Pressure is force divided by area, force per unit area. Force, we know mlt minus 2, correct? Area already given L square, simplify, so we'll get m, this is 1, this is 2, so this becomes minus 2, 1 minus 2 minus 1, so ml minus 1 t minus 2 is the dimensional formula, okay? So that's of the pressure, ml minus 1 t minus 2. Yes, okay. And the last now, power. Power is work by time. Rate of doing work is called power. Work is ml square t minus 2. Correct, no? From the previous discussion. Divide by time t. Rearrange. What do you get? ml square t minus 3. ml square t minus 3. So this is the dimensional formula. Okay. So do remember all these formulas. These many formulas are enough to understand all the rest of the topic. Okay. Let me repeat. Area L square, volume L cube, density ml to the power minus 3, velocity or speed Lt minus 1, momentum or impulse mlt minus 1, acceleration it's Lt minus 2, force, weight, tension mlt minus 2, work or energy ml square t minus 2, pressure or stress ml minus 1 t minus 2, and finally the power, which is ml square t minus 3 is the dimensional formula. So just write the physical quantities and then practice. And I should just write practice because they are very, very important from all exam point of view. Okay. So hope it is clear as what is dimensional formula. So a dimensional formula is a formula in which a physical quantity is expressed in terms of the fundamental quantities. You can see mass, length, time, mass, length, time. Everywhere, you will get fundamental quantities, ml, t, m, l, sometimes only l and t, sometimes only m and l, like that. So that formula is called as dimensional formula. And based on that, we can write the unit. For example, I want to write the unit of work. Mass, kilogram, mass in kg, length in meter square, time, second to the power minus 2. See, that is the unit of work, and that is also equal to 1 joule, because joule is the basic unit. Okay. So using the dimensional formula, you can write unit of any physical quantity very easily. Okay. All right. Now, all the physical quantities which are there in entire physics, they are categorized into 4 groups, like 4 family. Which are those? First one, dimensional variable, non-dimensional variable, dimensional constant, non-dimensional constant. What do you mean by variable? The value that varies is a variable. The value which varies is a variable. So here we have mass, example mass. So I have two objects here having different masses. Different value is different, right? The mass of this is different. So that means mass is a variable. Whether it has a dimension? Yes. What is the dimensional formula of mass? M. So that's why mass becomes a dimensional variable. A quantity having dimensional formula that varies is called as a dimensional variable. Clear? Any physical quantity which is a variable having dimensional formula is called as dimensional variable. Just now we have listed, right? There are about 10 to 12 dimensional formula I have listed. Velocity, momentum, area, volume, force, pressure, work. They are all dimensional variable. So example for dimensional variable I have already listed because these are the quantities which vary and they have the dimensional formula. Hope that is clear. Next one, non-dimensional. That means there is no dimensional formula. Non-dimensional variable. Okay, non-dimensional variable. Example, one of the example I am going to give, refractive index. A refractive index is a physical quantity which has no unit. Why it has no unit? Because it is measured by the ratio of speed of light in one of the medium to the speed of light in the other medium. That's how we measure. So what is the physical quantity? Refractive index. Speed by speed. If I try to write the dimensional formula here of the speed, LT minus 1, divided by again LT minus 1, they get cancelled. So that's why there is no dimensional formula. That's what is called non-dimensional. But is it a variable? Yet it varies, correct? It's because refractive index is different for the different medium. It's not for the same medium. For glass, the refractive index is 1.5. For water, it is 1.33. For diamond, it is 2.4. It varies from medium to medium. So do we have any other example? Yes. So one is refractive index. The second one, efficiency is another. Okay. The third one is a strain. So later I will explain what it means actually. For timing you remember. So therefore give example for a non-dimensional variable. These are the three. Which are all? Refractive index, efficiency, strain are example for non-dimensional variable. That means that they don't have unit, they don't have dimensional formula. So the conclusion is that it's not necessary that every physical quantity is a must have the dimensional formula. No. So these are the example. No unit, no dimensional formula, but these are variable. Okay. So hope it is clear. The second group of physical quantities. The third one, dimensional constant. What do you mean by dimensional variable? Quantities that varies having dimensional formula are called dimensional variable. Dimensional constant. So there are again certain physical quantities whose value is fixed. It doesn't vary. But they do have dimensional formula and such constant are called as dimensional constant. Now you must have heard of the constant called gravitational constant, isn't it? Gravitational constant, capital G. Correct? Having value 6.67 into 10 to the power minus 11. And it has a unit. The unit is Newton meter square per kg square. Moment there is a unit, there has to be dimensional formula. So quantities which are constant having dimensional formula are called as dimensional constant. So example, gravitational constant. Then we have gas constant, Planck's constant, Stefan's constant, Rydberg constant, speed of light in vacuum, which is small letter c, 3 into 10 to the power 8 meter per second. So these are all constant values. Okay. So hope you have understood. I have given enough example for dimensional constant. And the last category, non-dimensional constant. constant like pi is a fixed value, correct? Pi 22/7, it doesn't vary. But there is no unit for it, it's a non-dimensional. So therefore, the value of pi is an example for a non-dimensional constant. Clear? Then value of there is a value e means an exponential value, okay, having value 2.718. So you'll understand that in maths what do you mean by exponential, okay? E stands for exponential. So these are all constant. What constant? Non-dimensional constant. So therefore, if at all there is a physical quantity, it should belong to any of these four categories. Variable having dimensions are dimensional variable. Next, variable without the dimensional formula are called non-dimensional variable. Constant having dimensional formula are called as dimensional constant, and the constant without the dimensional formula are called as non-dimensional constant. Okay. So I have given example for all the four. Now let's go through the question that has appeared in the examination. Okay, which are the question that they have asked so far from this particular chapter. Okay, right. The question in the year 2015. What is the question? Write the dimensional formula of density. So we have learned all the basic, right? Dimensional formula of density. So what do you have to write? M L to the power minus 3. So this is the form. This is the answer to that question. Write the dimensional formula of the density. So one more question. Write the dimensions of the force. You have to write the dimensional formula of the force. Force is mass into acceleration. Mass acceleration is LT minus 2. So this is how you will be able to write, only when you know this dimensional formula by heart. Okay. So practice. So everything you can remember very easily. Okay, next one. Write the dimensional formula for impulse of a force or momentum. They have the same dimensional formula, right? Momentum. Momentum is mass into velocity. M LT minus 1. LT minus 1 is velocity. If you multiply by mass, you will get formula of the moment. See, these are all very easy, direct question. Only this much to write in the exam. Are you following what I am explaining, students? Okay, let's see next question. Write the dimensional formula of the first work and the power. So work is ml square t minus 2. Work. Power ml square t minus 3. The last dimensional formula. So for those two tables are there, just study very thoroughly. Okay. The next question. Mention a physical quantity. This is not from the exam. Mention a physical quantity which has unit but no dimension. Yes, this is something different. There is a unit, but there is no dimensional formula for it. And there are two such physical quantity. One is a plane angle. It has a unit, radian, but there is no dimensional formula. Then solid angle, steradian, correct? Yes, R. Plane angle theta is the symbol used. Is equal. Why there is no dimensional formula for it? S is what? Arc length. Arc length. Dimensional formula is L. R is the radius. Again, that's measured in L. That will get cancelled. So there is no unit for it. Clear? There is no unit. Sorry, there is no dimensional formula. So this is a physical quantity having unit. Physical quantity having unit but no dimensional formula. Hope it is clear. So that's what this particular question is all about. Okay. Next. Mention a pair of physical quantities having same dimensions. So I have given a large list of physical quantities. Speed and velocity, impulse and momentum, work and energy, force and tension and weight, pressure and stress. See, so when you have tried only one such pair, you don't have to write everything. Clear? Mention one dimensional constant. So this is a question from the exam. Dimensional constant, gravitational constant, gas constant, Stefan's constant. There is a constant called Boltzmann constant, Rydberg constant. There are so many. Again, do remember any one out of it. Okay. Mention a physical quantity which has neither dimension nor a unit. Mention a physical quantity which has dimension or a unit. Plane angle and solid angle are the physical quantities having unit but no dimensional formula. But what we wanted here, mention a physical quantity which has neither dimension nor unit. I had given just an example for non-dimensional variable. Remember those are three. One, refractive index, efficiency, strain are the example for this. Okay, physical quantity which has neither dimension nor a unit. Hope all these things are clear to you all. There is one more question which has repeatedly asked in the examination. What are the uses, what are the advantage of the dimensional formula? Repeatedly asked question, it has appeared 5 times in the exam. Now there are two uses are there, two advantages are there. Advantage number 1. The dimensional formula is used to check the correctness of an equation. What is the first use? Checking the correctness of an equation. And the next one, to derive the relation between different physical quantities. These are the only two uses. First one, checking the correctness of an equation, and the next, deriving the relation between the different physical quantities are the two advantages, two applications of the dimensional formula. So what do you mean by checking the correctness of an equation and how to derive the relation between the different physical quantities? For which you must be very thorough with all these dimensional formulas. So that's why I'll give some time so that you can revise and be ready. And both these two applications with the example I'm going to explain in my next class.